Good afternoon. This is Tom Lowry, and I will be your moderator for this afternoon's session. With me is Mike Bowers. We are both energy engineers with Amec Foster Wheeler and share a passion for reducing HVAC energy consumption and operating costs. Combined, we have almost 40 years of experience with all aspects of efficient HVAC equipment, including design, condition assessments, increasing efficiency, measurement, verification, and evaluation of vendor claims for HVAC efficiency improvements. This experience encompasses over 240 million square feet of conditioned space, including 125 million square feet of government space and more than 3,000 buildings. In this session today, we will discuss the variety of ways that a direct expansion system can experience efficiency losses and the best ways to overcome them. After a brief discussion outlining the methodology behind how we measure the actual efficiency and capacity of DX equipment, we will look at three different retrofit technologies that claim substantial energy savings, as well as the analysis we conducted for our clients in an effort to determine if the claims proved reliable. The final portion of the presentation will hopefully provide some guidance on how to get the most HVAC savings from your existing DX equipment, and the results may or may not surprise you. With that introduction, I'll now turn it over to Mike Bowers, PE, as he covers the bulk of the material in today's presentation.
Thank you, Tom, and thank you, Nicole, for the introduction. And thank you guys for joining us today and your interest in exploring options to improve DX efficiency. As they mentioned, if you have any questions about the presentation, please use that Q&A box and we'll try to get to them. So to start off, give a little introduction about myself. I'm a graduate from the University of Florida in 2011 with a Bachelor's in Mechanical Engineering. I worked at Heat Pipe Technology for the first portion of my career. The bulk of my career has been spent in HVAC energy efficiency, both on the manufacturing side and on the consulting side. Spent about 6 years in the HVAC industry, and since being with Amec Foster Wheeler, I've audited over 9 million square feet of space, resulting in projects that exceed a 20% ROI. Tom Lowry is moderating today's presentation, and he is the Director of Energy Programs for Amec Foster Wheeler, has personally audited over 240 million square feet of buildings, and has been concentrating on energy reduction in HVAC since the 1990s, leading efforts in testing efficiency gains from HVAC modifications, maintenance, controls, and aftermarket retrofit enhancements. So today's presentation will start off going over some widespread issues that we have found in our government and commercial facilities that we have been auditing and testing. We will then identify some reasons for DX efficiency degradation at the facilities and the units that we have seen. We'll go over some ways to properly assess condition of a DX system, and we'll go over some retrofit products that our clients have asked us to test that have energy efficiency gains that they claim. And then we'll go over some easy tune-up and minor modifications that will help increase energy efficiency at a more reasonable level, followed up by a brief summary and discussion. So in the past 12 to 18 months, Amec Foster Wheeler has conducted testing at 20 different federal and commercial sites nationwide. We are located in Gainesville, Florida. A majority of the sites have been in the state of Florida, although we have had some tests, some federal tests over in South Carolina and in California as well. Overall, there's been 84 circuits tested. Units varied in location, tonnage, age, and system type, but they were all DX equipment. Our comprehensive tests discovered that of the 84 circuits tested, 79% of them had an underlying issue that is simply just being missed by the maintenance staff. We'll go into these different issues in detail later on, but just want to make it clear that these issues are widespread. As I said, 79% of the units have an underlying issue that is just being missed by maintenance, whether that could be refrigerant issues, airflow issues on the condenser side or on the evaporator side, anything of that nature that can be fixed with simple minor repairs. and again, current HVAC technicians and maintenance contractors at these facilities have simply just missed these issues or misdiagnosed what could be wrong with the unit. So our claims and our findings, rather, have been supported by separate tests by a local consulting firm as well. They did 30 units across 3 different Department of Defense installations, one at Cape Canaveral in Florida, one in South Carolina, and one at Fort Irwin National Training Center in California. Their findings were that 87%, so 26 of those 30 units, had significant energy efficiency degradations of 20% or more. So these units are these issues are very widespread among these units. A DX diagnostic study is the best way to unearth these issues and make sure that you have a full idea of what is going on with the units and what's the best ways to attack them and remediate those issues. A proper DX diagnostic study can pinpoint underlying issues and allow you to make smarter decisions, such as cleaning the evaporator or condenser coil, maybe allowing some better airflow across those coils, maybe balancing the refrigerant levels, tightening or even replacing fan belts, or maybe the best option is a retrofit product that may be able to increase the performance or the efficiency of the unit. But without a proper diagnostic study, you will not be able to tell exactly what the best route is. Again, at a majority of these facilities, there are some significant issues. Some of them can be fixed right off the bat with a simple repair. Sometimes maintenance just can't get to the unit, be able to replace filters, and that turns into dirty coils. Maybe there's some fan belt that hasn't been that's been running loose for a couple months, causing decreased airflow and decreased performance and efficiency. So these are all things that a DX diagnostic study from a third-party entity should be able to pinpoint and identify. So most contractors and maintenance staff, they don't maintain equipment with energy efficiency in mind, so they may not be aware of the best ways to save energy with their DX equipment. So it's very important that an independent verification from a third-party entity take place to make sure that these maintenance practices are the best for your facility from an energy perspective. Just to piggyback off that, NREL has a study and an article saying that the absence of a sufficient annual professional maintenance routine can triple the rate of degradation. So anything with degraded coils or loose fans or dirty coils, without those things just compound over time. So without a proper maintenance routine, the rate of degradation on these units can increase by as much as 3 times. That DoD study that I mentioned a minute ago, they found that the existing units, of those 30 units, they all degraded and deteriorated by an average of 35% throughout the life of the equipment. And these are all degradations that can be repaired fairly simply with either coil cleanings, minor repairs such as correcting refrigerant charge or tightening fan belts, things of that nature. They can provide instantaneous energy savings of averaging 22% with a simple payback of just under a year for the most part. So again, these are things that may be missed that are causing not only energy degradation or efficiency degradation, but also decreasing the life of the equipment and can be repaired fairly simply. And a DX diagnostic tune-up from a third-party entity is the most recommended route to provide a real good comprehensive diagnosis. That way you can make smarter recommendations for your client and for this unit, and possibly make inexpensive repairs with an inexpensive tune-up that will provide quick paybacks from energy savings and extend the equipment life. But it may also unearth some possibilities for some retrofit products that we'll get into as well. So let's talk about the efficiency of a DX system. There are several different metrics to discuss the efficiency of a unit. We've all seen EER, the coefficient of performance, SEER and kW per ton for chillers. One you may not be familiar with is EI, but that's something that we'll go into in a little bit as well. That's simply the efficiency index, and that's a percentage of the actual efficiency, the actual operating efficiency, as a fraction of what is expected and what the unit should be operating at. It really gives you a good snapshot of how the unit is running versus how it should be running. But essentially, all these efficiency metrics, all they are is how much capacity a system is delivering for the energy it is using. So in order to increase that efficiency, you always want to try to decrease the energy consumption for that unit. The efficiency of a unit can degrade in several ways. It could be a dirty or degraded coil, a deteriorated coil. You could have a dirty coil on the inside or on the outside, on the condenser or the evaporator. You could have impeded airflow through a dirty filter or a dirty coil or maybe pinched ductwork, or you could have a non-condensables or any kind of oil buildup inside the refrigeration cycle itself. So these are all just a few ways of how the efficiency can degrade in a DX unit. So the DX system, the refrigeration cycle, is an entire system of many moving parts. So in order to get a good understanding of how the unit is operating efficiently, you have to really analyze each component. So several different things can happen with that can cause efficiency degradation. Unbalanced refrigerant levels, maybe a restriction in the refrigerant flow. Liquid can be flooding back to the compressor, maybe through a improper airflow on the evaporator side. You can have a corroded condenser coil, maybe a dirty condensing coil. Your expansion valve may get stuck open or stuck closed, causing some refrigerant flow issues. You could have a dirty coil on the evaporator side, or maybe a dirty filter as well, or any kind of restriction in airflow will not allow the heat to transfer properly on either side, causing a decrease in efficiency overall. So low condenser airflow, evaporator airflow, maybe low refrigerant or too much refrigerant, refrigerant flow restrictions, or any other mechanical issues, these all result in a poor and inefficient heat transfer, and that can result, or it does result directly to a decrease in efficiency, and you're essentially just throwing your money away. There's some easy opportunities here to save some money for your client and for your building. So the best way to find out what exactly is going on with your unit and measure the efficiency and really get a snapshot of how the unit is operating is a DX diagnostic service. And a detailed analysis can provide insight as to how the unit is operating and can really indicate and pinpoint some issues that may otherwise go unnoticed. So it is an invasive product, and it does require an EPA certified personnel to do the study and the diagnostic survey, but by measuring the pressure and temperatures from both the liquid and the suction line, and also the supply return and ambient temperatures, you do get a good snapshot of how the unit is operating and can really tell exactly what's going on with that unit and be able to identify some possible solutions as well. So this is a snapshot of a test that we did recently here in Florida. This is I believe this is a 7.5 ton unit, and we added 6 tons of refrigerant. You can see here on the bottom that there was, the pre-test said to add 6 pounds of refrigerant. Sorry about that. It was a 7.5 ton unit. We added 6 pounds of refrigerant, and you can see the pre-test and the post-test indicated that it is now an acceptable, safe, and reasonable performance. This next screen here goes into more of the technical side and the technical diagnostic survey, and it shows you that the superheat was high, subcool was low, indicating a low refrigerant. And after we added the refrigerant, everything kind of was in line as it should be, and the efficiency index increased 20%, and the capacity index increased 24% as well. So we really, just by simply adding refrigerant to this unit, we were able to increase the efficiency and the capacity and provide instant energy savings, and provide them really with the unit that the building paid for and should have had in the first place. So once you know the condition of your unit, what's the next step? What are some possible solutions that you can take to really fix your unit and make sure it's in good operating condition. So our client asked us to explore a few different retrofit technologies in an effort to validate their energy savings claims. We tested a condenser coil fin oxidation degradation coating that will prevent fin oxidation and corrosion. We also tested a synthetic catalyst that will reduce the oil fouling in refrigerant lines. And we also tested an evaporative cooler for condensing units. So we'll go through each one of these technologies and the test that we did. First was a coil coating on the condenser coil. So according to vendor literature for this particular coating, it's an inorganic coating for DX coil protection and rejuvenation that will restore the coil to its original state. It's a thin coating that allows for maximum heat transfer, but also allows for proper condenser coil airflow. And they advertise a 13% energy savings just by coating the condenser coil. So the idea behind it all is you can have a dirty condenser coil or maybe a corroded condenser coil, and that all yields insufficient heat transfer and a decreased efficiency. So a clean protected coil will increase the heat transfer surface area and also prevent degradation and extend the life of the equipment. But purely on the energy side, there are energy savings associated with it as well. So again, the vendor claimed a 13% decrease in energy consumption. Amec Foster Wheeler did our own independent study, and we found an increase in efficiency ranging from 2 to 12%, depending on the condition of the coil. So we really found that, yes, there are energy opportunities or energy savings opportunities here for this coil coating, but it may not be as high as the vendor claimed. The next technology that we've tested is an oil fouling reduction synthetic catalyst inside the refrigerant cycle. So according to vendor literature, it's a synthetic catalyst that will reduce the oil fouling in refrigerant lines, and it'll help restore the system to its original capacity. You can see from this diagram here on the bottom, the idea behind it is that oil fouling exists on the inside of the refrigeration tubes and doesn't allow for proper refrigerant flow, and it doesn't allow for proper heat transfer, doesn't allow the refrigerant to transfer heat to the coils and to the outside. So adding this synthetic catalyst will reduce that oil fouling, allow the refrigerant to flow better, and allow proper heat transfer between the refrigerant and the copper tubes. So they guarantee a 10% reduction in energy consumption. They claim that they average between 15 and 23% energy savings. So this, again, the idea behind this is just like clogged arteries prevent proper blood flow and can lead to a lot of medical conditions, a clogged refrigerant line with some oil fouling can cause inefficient heat transfer as well and can lead to several mechanical issues, including an inefficient DX unit. So the vendor guaranteed a 10% savings, and they claim an average between 15 and 23% decrease in energy consumption. Amec Foster Wheeler's independent study found an increase in efficiency ranging from 0 to 3%. There were some units where we really couldn't see anything at all. There were some that we did see a 3% increase in efficiency. Real story here is, you got to really know what's going on with the unit before you decide to just blanket cure, put a certain retrofit product onto your unit. Really got to do a real good diagnostic test before you know what's going on with your unit, before you know the best route to take. The third retrofit product that we tested is an evaporative cooler for a condensing unit. Essentially what it does is it hooks up to a simple garden hose, and it provides a fine mist to the outside of the unit and allows cooler air to flow through the condenser unit. It advertises up to 30% energy savings. So the way this essentially works is you have refrigerant flow flowing into the compressor, then into the condenser, and you have airflow going through that condenser coil, picking up that heat and rejecting the heat to the outside. If you spray a mist using this product, it will decrease that outdoor air and essentially increase the capacity of the unit. And the theory is it will save up to 30% energy savings. So when Amec Foster Wheeler did our independent study, we were able to see an increase in efficiency ranging from 6 to 10%. So although it does provide an increase in efficiency, again, it's not as high as the vendor claimed, but more importantly, it's not just a blanket cure for every unit. Perhaps this would be kind of a good interim measure on an older unit that may be unable to meet capacity, or maybe you have a project that you don't have the capital to replace a unit and you need that extra boost just to kick it along for a couple more months or maybe through the cooling season. This may be a good application. So the big takeaway after these tests we found is retrofit products may not be the best way to increase the efficiency of your unit. It doesn't matter how many bells and whistles you put on your unit. It really doesn't. There is no blanket cure for everything. There is no kind of magic elixir that will increase the efficiency of your unit. You really have to know exactly what's going on with your unit to be able to make smarter recommendations. A DX diagnostic tune-up is the best option to simultaneously extend the life of the equipment and obtain immediate energy savings. So in order to really obtain those energy savings and extend the life of the equipment, you really need to know exactly what's going on with the unit and make sure that the simple repairs are done first before you explore any other option. So your first step should always be a DX diagnostic service. So a proper system evaluation will unearth the hidden issues, as we said, and it will also provide insight to the system performance. During our tests of 84 different circuits, we found the average efficiency index for units with mechanical issues is 74%. So what that essentially means is of all the units that we tested, if there is a mechanical issue, that decreases the efficiency index, it decreases the efficiency rather by 26%. And a simple tune-up that can be guided by your DX diagnostic survey can increase the efficiency index and also increase the capacity, allowing the system to operate as designed. It will increase the performance, increase the life expectancy, decrease the runtime hours, and overall decrease power consumption. So of the 84 different circuits that we test in the federal and commercial space, here's the overall summary results of the test that we did. So 21% of the units didn't have an issue, and there was an average efficiency index of 95, which is to be expected, within range. Really no issues with the unit. There isn't really any efficiency increases that can be realized here. Go down one, the refrigerant issue. Nearly 60% of the units had a refrigerant issue, whether that's low refrigerant or an overcharge, and that decreased the efficiency substantially down to an 81 efficiency index. Thermostatic expansion valve was also a minor issue on some of these units, but that really decreased the efficiency quite a bit. And there are also other issues, kind of one-off issues, whether they're non-condensables or inefficient or insufficient airflow on the condenser or evaporator side. Overall, for the units with mechanical issues, there was an average of 74 EI for those units. So there's definitely some room for improvement on all of these units. And remember that DoD study as well, that they showed an even larger decrease in efficiency of up to 35%. So 79% of the units that we tested had an easily correctable issue that created an average decrease of inefficiency of 26%. A simple mechanical tune-up and simple mechanical repairs can be the easiest and most effective way to increase the life of the equipment, but also to decrease energy consumption. And as I said, most problems are just simply being missed by local maintenance staff or local contractors that are working on the unit. So these minor repairs one of the minor repairs we can do is refrigerant balancing. A low refrigerant charge will decrease the capacity of the system and can also cause damage to the system. While it can increase the efficiency of the unit during off-peak conditions, it will ultimately increase the energy bill by increasing the runtime in the peak seasons, because is not reaching the capacity, and overall the unit will just simply not be running as it should. An overcharged system will increase operating pressure and temperatures of the system and cause system cycling that will reduce the life expectancy. Overall, it will increase the energy bill by increasing that head pressure and making the compressor work a little bit harder. So balancing the refrigerant levels, whether that is adding charge or removing charge for that particular unit, whatever is unearthed by the DX diagnostic survey, will extend the life of the equipment, and we found it can increase the efficiency and the capacity by as much as 20%. So simple repairs, just like adding refrigerant if needed or removing refrigerant if needed, it can increase the efficiency by as much as 20%. But just because adding refrigerant to some units can increase the efficiency by 20% doesn't mean that this is just a magic elixir. You've got to keep in mind that 80% of a DX unit's energy is being used by the compressor, and 100% of that compressor energy is used to fight head pressure. So what that means is adding refrigerant may actually increase the efficiency or increase the energy consumption of that unit. So you really have to do a full diagnostic survey to make sure that that is the only issue. If there's low airflow on either coil, it may actually increase the efficiency, energy consumption of that unit. So a full diagnostic survey is definitely recommended, so you don't just add refrigerant and increase the energy consumption. HVAC systems are systems, and you really need to make sure you analyze each mechanical component. That way you aren't stuck doing the wrong repairs for that system. There is no simple cure. Each and every component has to be considered before you make any repairs or recommendations. So of the 19 packaged units that we have checked so far, 5 of them have had significantly loose or damaged belts. We came across one that the belt was snapped off completely and the unit had been running for a few days, completely iced up coil. So it's not for lack of trying. This maintenance staff, sometimes they're overworked, sometimes they can't really get to each site or each facility in their on their list. So at the end of the day, a lot of these things are just simply being missed, and we found that tightening the fan belt or replacing the fan belt can increase in the energy efficiency immediately. So loose or damaged fan belts will decrease the supply airflow across the evaporator coil and will also decrease the capacity of the system. Low airflow will actually cause the evaporator coil to freeze and will increase the energy bill substantially because you're not getting enough capacity or you're not removing enough heat from the space. A quick, inexpensive repair by simply tightening the belt, or if need be, replacing the $15 to $20 belt can increase the efficiency by 10% immediately. So it's a very inexpensive repair that can be made that will automatically increase the efficiency and save you and your facility money right away. Another thing that is simply being missed is filter replacements. You're supposed to be replacing the filters once a month or once every 3 months, but a lot of times in these federal and commercial facilities, it just simply is not happening. Dirty filters will decrease the supply airflow and can lead to a dirty coil, and again can cause icing on the coil as well. It will decrease the capacity of the system, kind of the similar symptoms from a broken fan belt. A dirty filter can do the same thing. So although sometimes it's missed and neglected, it is a big deal and can increase your energy bill. And our findings showed that there's a measurable increase in efficiency of 8% and a measurable increase in capacity of 4% by simply changing clogged and dirty filters. So the main takeaway here is that a thorough third-party diagnostic evaluation followed up by a comprehensive tune-up will increase your capacity, increase your efficiency, and prevent major issues from arising. Here, this picture here was that unit that we were talking about earlier that was completely iced up. Again, there is a maintenance staff on site, and it was missed for a couple days here. It's just things that are being missed by maintenance staff and local contractors that are working on these units that are actually resulting in major energy degradation and efficiency degradation. So a third-party diagnostic evaluation is really stressed here because we need to make sure that we get a fresh pair of eyes. Whenever you write a report, you get somebody else to look at it. It's never good to review your own work. Same kind of concept here. You really need to get a fresh pair of eyes on the unit rather than getting the same people to look at it and look for new things. Again, when considering retrofit products, beware of vendor claims. As we talked about earlier, the coil coating vendor that we worked with claimed 13% increase in energy savings. We found 2 to 12% depending on the condition of the unit. The refrigerant synthetic catalyst that reduced oil fouling, they claimed a guaranteed 10%. We found negligible 0 to 3% increase in efficiency. And the evaporator coil on the condenser side, the vendor claimed 30%. We did find 6 to 10% increase in efficiency. So all in all, really beware of vendor claims and do your own due diligence before recommending any products. But again, the best way to save energy for the least amount of money is to really not use any retrofit products. There are some applications where retrofit products are the most beneficial, but a DX diagnostic tune-up and a DX diagnostic survey is the best way to really pinpoint what is going on with your unit and what exactly would be the best route. And minor repairs will save easily up over 20% of energy consumption for your units. And as always, the saving potential is maximized by a proper diagnostic analysis of the equipment. You really have to know exactly what's going on with your unit, and it's best to have a third-party entity do that for you. In order to deliver the best solution for your building or for your client, you have to know what the problem is. You can't go in there blind, so a thorough DX diagnostic evaluation is definitely recommended. And a tune-up may be the most effective, and it is definitely the most inexpensive way to increase life expectancy and decrease your energy consumption. So I definitely recommend getting a thorough DX diagnostic evaluation for your units. So a DX diagnostic tune-up and survey will, as I said, it can pinpoint some issues and problems, but it may also allow you to provide smarter recommendations for different different retrofit products. If, for instance, if you have an oxidized coil, maybe a coil coating is the best and safest route. Maybe if you have an older unit that's unable to meet capacity, it is probably a benefit to have a evaporative cooler on that condenser unit to kind of kick it along and allow you to get the capacity and the efficiency that you need. So all in all, you really need to figure out what's going on with your unit. Unless these guys are your clients and they're just sitting on a bunch of money, you need to make sure you're spending their money wisely and making sure that you save their money and their energy bills as well. Well, thank you for your time. If you guys have any questions, again, please feel free to use the Q&A box.
Okay, thanks, Mike. And we have had some questions come in, so I will read these and provide answers. So the first question was, would a visual non-invasive inspection from a qualified technician be sufficient to determine the proper repairs? The answer would be, we don't believe so. We recommend an invasive inspection, possibly on a representative number of the units that you have, to see if it serves as a quality check on the maintenance that's being performed, if nothing else. Next question, will a PDF copy of the presentation slides be available for the participants to download? I believe that question was somewhat answered by Nicole at the beginning. Within 3 days, you'll get a link to download that and the presentation and anything else that you might want. How often do you recommend an owner conduct a tune-up on DX units each year, 2 years? I think that we would recommend a population sample be done, and depending on the results of that, if your existing maintenance is being done well and most of the units come back in the 90 to 95% of EI that we would hope to see, then you probably don't need to do that very often. If you get bad results on your first study, then you may want to build that in regularly or change your maintenance provider if that is an option for you. Question, how do we get the PDH credits? I think Nicole addressed that, but if not, Nicole, can you answer that question?
I'm sorry, can you repeat the question?
Question is, how do we get PDH credits?
So all registered attendees will receive a PDH certificate via email within 3 business days. Basically, I'll send out a PDH certificate, a recording to the presentation, as well as a PDF of the presentation. But please just be patient. It'll come out in 3 business days.
Okay, thank you, Nicole. Next question. On the difference between your analysis and vendor claims, did you review how they calculated savings so you were comparing apples to apples? Absolutely, we did. What we saw was a total attribution of cooling kilowatt hours to cooling degree days. So they neglected entirely the base load and put all of their savings based on a linear relationship, a pure linear relationship with cooling degree days for the given territory, resulting in overstated energy savings. That's the executive summary answer for that. Next question, do you have data on how properly maintained equipment degrades over the equipment lifetime? That is an excellent question. In 2004, we did a comprehensive study for the Environmental Protection Agency at 150 package units in North and South Carolina. We did exhaustive research with different manufacturers of equipment. None of them could provide us with any information on that. Our findings and observations dating back to that time are that the majority of units contain an aluminum coil, a copper coil, which is with aluminum fins pressed fit over them. This puts dissimilar metals into contact with each other, and that is the biggest indication of degradation, rapid degradation in the efficiency performance of units. These dissimilar metals exacerbate the degradation process. With your higher efficiency units today, you're seeing a lot more aluminum on aluminum, which does not have that same issue, so it degrades much slower. But if you've got an aluminum fin and copper coil and it's 2 years old and you're in a humid environment or a place where it rains, basically non-desert, we would estimate at least a 12% degradation in that unit. Compressors, we don't see quite the same degradation with them, and that's a little more hit or miss. So I guess we could confine that to correctable efficiency issues. There are those which are correctable and those which are not. Okay, moving to the questions are piling up now. I love the bottom line truth findings. This presentation would be great at JETSI and energy-specific conferences as well. Okay, thank you. Not a question, just a compliment. Okay. Next question, did you compare cost of maintenance, labor and material versus efficiency on units? Some organizations run units to failure, or which maintenance should be done as a minimum? No, we did not do that. The cost of the diagnostic service, if there's a good population of units at a given site, you're in the $100 a unit category, we would expect the payback on that to be less than a year. Unfortunately, units get installed improperly charged, typically on day one. At one site where we looked at this, it was suggested that we not even bother with checking refrigerant charges. They had 10 new units that were 10 tons or bigger, and they had been installed in the last 3 months. Of those 10, one had the proper charge, and the others are off by plus or minus 20%. So the day those went into service, they were charged incorrectly, which should have been done at the factory. So don't know how that happened, that they came in that off, but they were. Okay, next question. What climates did you conduct your independent tests? Did the performance of the vendor solutions perform better in multiple climates? Southeast and the humid was pretty much, from North Carolina to Florida is where all the tests took place. The one that we would expect to see different performance from the most would be the mister. Want to caveat that by saying that for the most part we're using city potable water. It could have varying degrees of hardness. As that water evaporates, it's going to leave a film or a crust or deposit on your fins. So we don't see that as a long-term viable option anywhere unless you're able to use condensate for that. There have been 2 other technologies we tested that you did use condensate for the misting portion, but we had problems with the filter pads lasting, tearing up, and uneven distribution of the water, so we did not see good results from those. Okay, well, on behalf of the Society of American Military Engineers and the Energy and Sustainability Committee, I want to thank all of you for attending this webinar today. May your day be sustainable and bright, and may your DX equipment be cool and run right. Thank you for your time today.